All right, so we're gonna design electronics dies. Okay, for this dies, is have a 6 different states. Okay, so you can imagine that the first states we can call it a number 1. Is display a 1 there, and at this state you're going to generate some outputs. Okay, so the output here you can see if you are at the first state, you are generate 0 0 0 1 0 0 0. So 0 0 0 0 1 0 0 0. Okay, what does it look like is you can only have a d in a third, so it's something look like this. Okay, and that's the first state. So I write the state name on the top and the state output on the bottom. Okay, and there is a second state, then you're going to generate a 1 0 0 0 0, and there is a 1. So 1 0 0 0 0 0 1. So 1 2 3 5 6 7. Okay, so in this case, if you draw that, we have that's A and G, and that's number 2. Okay, you see the pattern here. So we're gonna have 3. Will not do the full version. You're gonna have 4. You have some output. You're gonna rate this one. Okay, number 4. You're gonna generate those, and the number 5. Okay, and you're gonna have number 6. So number 6 will light up something look like this. Okay, that's the dice you're gonna light up on this panel. Okay, so what happened here is you're gonna go from one state to another, right? So it's just if you are at the first state, the next state will be 2, next state will be 3, 4, 5, and 6. If you're at a 6, the next state will be 1. Okay, this is the state diagram. You're gonna go loop like that. So now we want to code each state. Okay, we want to give each state a code. So in order to represent 6, unique states, you need at least 3 bits, because 4 bits only give you 2 bits only give you 4 unique combination, right? 3 bits can give you 8. So we're gonna use 6 of them. So first one we give a code called 0 0 0. Okay, that's code. We're gonna code the states. The second states, instead of a binary number, we give a different code here. So this is called a crimping code. Okay, 0 0. If we code this way, you can see this 1 start to push, and 1 1 1. Okay, and then 0 goes back and push this 1 to the right hand side, and 0 0 1. So for the number 6. Okay, number 6, or the row number 5. Okay, the same. So the rest of them, I think here is a typo. We're gonna use cross. Okay, we use cross. We don't care the other. So we only have 6 faces. All right. So if you code this way, that will be clear. When you add this row number 1, so state number 1, the next state will be state number 2, and state number 2 code is 1 0 0. Okay, and if you are here 1 0 0, the next state is state number 3, which is 1 1 0. Okay, we just give a code name so we can build that truth table. All right, so etc. And until you're at 0 0 1, then you go back to 0 0. So for the other two, because it's never gonna happen, so we don't care what's the output is. Okay, so the next part is we want to implement this. So that's the main part. You have the current state code, and you have your next state code. We're gonna use these two parts to build key maps. Okay, and to simplify the circuits. So here we want to use a DFF. The question asks using DFF. So where this Q1, Q2, Q3 from is just the output of the Q. Okay, you can say this one is the Q1, and if you have another DFF D flip-flop, this will be Q number 2, and you will have another Q number 3. Okay, and the D1, D2, D3 gonna be the input for each D flip-flop. Okay, so how to connect them? Right, so that's the D1, D2, and D3. How to connect them is need some kind of design. All right, so you can see the D1, D2, and D3 is just copy down what you have for the next state. So that means, let me use a highlighter. So whatever you have here is your input for the truth table, and then you're going to do it one by one. So you're going to use this line to design D1, and you use this input again, use D2 as output to design another circuit. So this is 1, 2, 3 key map, gonna design the whole thing. All right, let's do one as example so you see how it works. Let's first draw a 8-bit key map. Okay, let's figure out the what's that, the location, because it's not the conventional order. So when we talk about binary number, we always go from 0 all the way to 0, 0 all the way to 1, 1, 1, right? This one is a different way of coding. This one, D1 here. Sorry, Q1 here. Okay, and we have Q2 and Q3 here. So 0 and 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay, then we know 0, 0, 0 is the first count or first row. Okay, first row is 0. So I just write the index here so we can fill the blanks easier later. And the second one, so let's look at this one. So this one, 0, 0, 1. So 0, 0, 1, we're looking for 0, 0, 1. 0, 0, 1 here is number 5. Okay, that's the row number 5. So I put a 5 here. And 0, 1, 1. So we're looking for 0, 1, 1, where 0, 1, 1 is row number 4. So we put 4 here. 0, 1, 0. So 0, 1, 0 is number 6. Okay, if you do that, you will find this is 7, this is 1, this is 7, and this is 3, and this is 2. Okay, so you have all the index, then we can start to do the circuit for D1. Okay, for D1, we're going to draw that cell, 8 cells again. Then we can start to fill in blanks. 0 is 1, 0 goes here, right? And the second one is 1, 1 is 1, 1 is here, right? 1 is here. Another one is 1, so number 2 is here. And 3, 4, 5, 3 here, 4 is here, 5 is here. Okay, the other 2 are X. Okay, so we can start make circle. Then we can draw 3, 4, 5, and 6, and 7 cross. Okay, so we can make a big circle like that. Okay, and yes, that's it. Okay, if that's the case, then we can easily get this Q1 is gone, right? So both 0 and 1 being covered, 0, 0, 0, 1, 1, 1, 1, 0. So this is a Q2 and Q3. Then you can see Q2 got 0 and 1, so it's covered. So it's just Q3. So D1 just equals to Q3. Q3 both are 0, so it's Q3 naught. D1 equal to Q3 naught. Okay. Then you can do this for D2. Okay, you can do this for D2. Just so these are the X. Okay, these are the X because we copy down from here. You will do the same thing, then you will find the expression for D2, D3. Okay, so things we got D1 equal to Q3 naught. Okay, so we can get this. So this is a Q, this is a Q bar, Q naught. So we can just connect this one with D1. That's the first one. Okay, and if you do everything, you will find this one will connect it with this one. Okay, they all being connected with the same clock. Okay, same clock. All right, that's the next day logic. All right, for the output logic, for example, for A, let's do one for A. Okay, for A, you're gonna draw that 8 cell K-map again. Then you know 0, 1, 1, 1 is 0, 1, 1, 1. Okay, and 4, this is a 4 and a 5 is a 1, 1. 4 and 5 is a 1, 1. The others are X. Okay, so if you know that, you can start to do your key map. You can find the expression. Same thing for B, C, D, E, F, G. Okay, so I will stop here and let yourself do the work. Okay. All right, so the tutorial 10 is exactly the same question. Okay. The only difference here is we're gonna do it use a JK flip-flop. Okay, we're gonna use a JK flip-flop. First, let's quickly review what is a JK flip-flop. Okay, so this is the table we got it from the lecture slides. So there is a J, there is a K. Instead of only one D, there's a J and K, and there is a clock. Okay, and there's a Q and Q bar. All right, so that's the diagram for the JK flip-flop. So if we summarize this table, you will see that for JK have different combination. We have a different kind of outputs. So Q, this and Q plus, which became next. So this will be the current state. This will be the next state. Okay. So if Q, both JK are 0, so you can see that this will be the no change state. So both, so whatever you have at the current state, you will send to the next state. Okay, and if your JK got a 0, 1, 0, 1, you can see no matter what the current state is, the next state is 0. So no matter what this is, the next state will set 0. And if 1, 0, so no matter what the current state is, the next state will always be a 1. Okay, if it's a 1, 1, then we actually toggle. Okay, that means if your current state is 0, the next state is 1, current is 1, next is 0. Okay, so if we know this, then we look at here. We know what the current state is, and we know where is the next state. So based on the state diagram we talk about in the tutorial number 9. And if we use a D flip-flop, okay, this table is very easy. You just copy down. So this is next state is 1, 0, 0. The D will be give a 1, 0, 0 here. So 1, 1, 0, so it's 1, 1, 0. Okay, that's very simple. But here we want to figure out what does JK looks like depending on the input and output. Okay, so if you look at this one, then you can summarize that what kind of a current states Q and the next state Q plus look like, and we want to figure out what JK should be. So we can, based on this, design a circuit to connect it with J and K. Okay, you need to have circuit for J, circuit for K for this 1 bit, Q1 bits, and you're gonna have another right, like here you will have a J1 and K1, J1 and K1 just for this bit, okay? Then you will have a J2, K2 for the second bit, and you will have a J3 and a K3 for the third bit for the states. Okay, that means you will have a 6 K-map to figure out the next state. All right, so first let's find out this. So if the current state is 0, next state is 0, what's the JK look like? And if this is 0, then this is 1, this is 1, this is 0, and 1, 1. You only have this 4 possibility here, okay? So if the current state is 0 and the next state is also 0, that's actually no change, right? So we can keep this one here. But if you look at it carefully, then if you have a 0, 1 as JK, you can also set the next state to a 0, no matter what's the inputs, what's the current state is, right? So actually, you actually have a 0x. Okay, so J has to be 0 and K can be anything. Can be 0, can be 1. 0, 0, 0, 1 all gave you the output equal to 0 if the inputs as current is 0. Okay, same thing here. So if you have a 0, 1, so if you're do 0, 1, this is like a toggle, right? This is clearly a toggle. You can put a 1, 1 here, will give you that. But you also set this one to a 1 no matter what, right? So 1, 0 also okay. 1, 0, 1, 1 both okay. So that means it's 1 cross. Okay. And the next is 1, 0. So the current is 1 next to 0s. Again, is a toggle. But also you can set, you can use 0, 1 to set it. So no matter this is, that give you that one. Okay. The last one, 1, 1. So it's actually keep it the same. Right, you are keeping it the same. So 0, 0 will do this. 0, 0 will give you that. At the same time, 0, 0 give you that. If you set this one, 1, 0 also give you that. Okay, so you can give x 0 here. So the last bit has to be 0, but the first bit can be 0 and can be 1. Okay, so let me double check if I got it right. I think so. That's it. Excellent. So if we got that, we can look at this bit by bit. So you figure out these two rows is, right? So now you want to pay attention to the Q1, this row, okay? And you want to pay attention to this row, this column. Okay, so this one is the Q1 is the current, and this one is the next Q1. Okay, so this is a 0, this is a 1. So 0 and 1. So current is 0, next is 1. So we give a 1x, right? J has to be 1, K can be x. Same thing here, 1, 1. Okay, you got a 1, 1, so you got x 0 here. Then you got a 1, 1 again, and then you got a 1, 0. 1, 0 is x1, okay, and 0, 0. 0, 0 is 0x, okay, and another 0, 0, so 0x. For these two rows, you can see this one's 0 and the next is x, right? So it can be 0, 0 or 0, 1. So it can be 0x or can be 1x. So that means j is x, right? So give us a lot of flexibility. So xx, same thing here. 1x can be 1, 0, can be 1, 1. So can be x1, can be x0. So is xx. Good. Okay. So same thing for the rest. You're going to fill in the blanks, okay? And you're going to do the JK, sorry, you're going to do the K map again. So I will quickly do it for J1, for example, okay? For, let me change the color, maybe this one. So for J1, you will draw a 8-cell K map. And if you remember that pattern, I forgot, so I will have to bring it up. So I don't need to read them all again. I'll do them all again. That is 0, 5, 4, 6, 0, 5, 4, 6, and 1, 7, 3, 2, 1, 7, 3, 2. Okay, so let's fill in the blank. The 0 is 1, and the 1 is x, 2 is x, 3 is x. Okay, and we got 4 and 5 are zeros, and the rest are x. Okay, so we only circle 1. We can got a big circle like that. If that's the circle, then Q1, Q2, and Q3. Then we got Q1 is crossed, 0, 0, 0, 1, 1, 1, 1, 0. Q2 crossed, Q3 is negative, right? So we got a G1 equals to Q3 negative. Okay, again you have a 3 JK flip-flop. So this is a Q negative. We'll go all the way back and connect it here. All right, so you're gonna do this for K1 and complete this one as well. All right, and do this A, B, C, D, E, F, G as well. Okay, pretty tedious, but is a good practice for you to get more understanding about those JK D flip-flop.